exactly. So 5.1 is on normal and standard normal distributions. There's not much of a difference between the two these days. I will show you how it was done in the past, but it is not necessary to look at a table and come up with the probabilities. You can get everything using your calculator. So we have seen normal distributions before. What type of histogram would it have? What shape of histogram would it have? Would we consider that to be a continuous curve? Yes. Yeah. So the data must be continuous. So this only works for continuous data, not discrete. And this is a continuous distribution. Let's say I tell you that the average of this normal distribution is 8. And I also give you the standard deviation has to be 2. We have done this before, right? Move one standard deviation to the right, we get 10, another 12, another 14. Same on this side, 6, 4, and 2. Do we remember the section where we did this?
Yes, empirical data.
Very empirical data.
Well, no, empirical distribution. Rule.
Empirical rule, but good job. So it is the empirical rule. What does that rule state?
States. So within 2 standard deviations, within 1 standard deviation of the mean, 68% of the data lies there. And 97% of the data lies within 2 standard deviations. 95%.
Help the poor guy out.
99.7.
And lastly,
99.7.
97.7. Very good.
Okay, that's right.
Good job.
That's so good, man.
Should I be drawing this out?
Yeah.
Right. So that is the empirical rule.
Yeah.
And it tells you the percent between the standard deviations. And how did we get those numbers? Mean is right in the middle, and x bar plus s, x bar plus 2s, x bar plus 3s. On this side, x bar minus s, x bar minus 2s, x bar minus 3s. Yes, that's how we got that. Now, I can convert the data here to z-scores. So first I'm going to subtract the mean. And then whatever answer I have, I'm going to divide by the standard deviation. We shall call the data as x. All I'm doing is I'm subtracting the mean and dividing it by the standard deviation. So if I take this data and went over here, do you believe that the shape of the curve will change? Would the shape change if I subtract the mean and divide by standard deviation?
Yeah, z-scores.
Yes.
So
no. So Amit asked me, is that a z-score? It absolutely is. So just because you change an observation to a z-score doesn't mean it is going to change the shape of its distribution. So
Scotty's perfect.
quadratic prime. Getting it right. Close. I'll leave it at that. I could spend an entire class period doing that. We should. Something good.
I think we should.
Okay, so what would the z-score or percent of it? 0. What about the value 10?
2. Wait. Yeah, 2.
No, 1. Yeah, 1.
Oh, yeah.
12.
2. 3. 4.
Six.
Negative 1. Negative 2. And negative 3.
Good. The shape doesn't change. The observations change from data values to z-scores. Whatever probability that I see between these 2 points will be different from the probability that I see between those 2 points. Do you agree or disagree? So 68% lies within 1 standard deviation of the mean.
Right.
I come over here, so within 1 standard deviation of 0 on either side, would the probability be the same?
Yes.
Or would it be different?
The same.
It has to be the same. So still 68, 95, and 99.7%. Good. Now here is something that you've got to understand about continuous distributions. What does that 68% mean? That 68% means the area under the curve is equal to 0.68. Does that make sense? So where do we get this magic number from, 68%? It is simply the area under the curve. Naturally, if I expand, the area has to increase. Yes?
Yes.
Which is why we go from 68 to 95. Yeah. Does that make sense? Who's having calculus? Calculus 1. Area under the curve. How do we find that?
Integral.
You integrate it. Very good. So you integrate this curve to find the probability. Unfortunately, this particular curve cannot be integrated directly. So we have to use a calculator.
Improper integration? Is it because it's an improper integration?
No, the function just cannot be integrated.
It's not X and Y.
So there is a table. The table did not give us an exact answer because this is an approximation for -2. The area below -2, it's 0.0228 or 2.28%. We're going to use the calculator now. Now, press second bars is the exact place where we used or where we got binom PDF and binom CDF from. So go to that list and tell me which function to use.
Normal, PDF or CDF?
Which one? Is it PDF? Is it CDF?
CDF.
Why CDF?
Approximation, and it's a cumulative score. Isn't it?
It's cumulative, right? We're not finding the probability of a single value. Do you agree?
Yes.
I'm finding the probability of less than or equal to -2. So that is a cumulative probability. So you have to use CDF. In this class, we'll never use normal PDF. Just keep that in mind, put it in your notes. We will never use normal PDF. By all means, the exact probability of a continuous distribution is 0. Right, that's the,
What did you say?
the exact probability of a normal distribution is 0. We will not be using it in this class.
So that means, well, in theory, that's just saying that if you're trying to find exactly -2, it would be 0.
Exactly.
And any other
You,
point.
you cannot find.
Okay,
The reasoning behind it is because we're trying to find the area under a curve, right?
right.
So area less than -2, I'm finding that area. And if you're looking at a single point, what is the area of a single point? 0. Does that make sense?
Okay,
Which is why you cannot find, or it is not meaningful
to
to
find.
find the exact probability with a continuous distribution.
Okay.
So we have to use normal CDF.
Good question.
Yes.
Find the area under the curve. Can you always use just binomial CDF in the calculator instead of integrating, or just for this case?
No, just for this case. If life was that easy.
You should make it that.
I am. So
Obviously.
if you have the newer version of the calculator, it will probably say lower, upper, mu,
Yeah. There, here. Yeah, numerator, yeah,
Sigma.
denominator.
lower, no, it's not FCDF, it's normal CDF. Very good. Lower, upper, mu, and sigma. Normal CDF, where did you guys get F from?
I don't know.
CDF.
I clicked that and it went there.
Normal CDF, the very second option.
Yes.
So lower is where the area starts. Upper is where the area ends.
It's like lower than the upper.
Exactly. So if we go back to that picture,
We're gonna have to write down that whole formula.
No.
That's almost really good.
let's say this is -2. Yes? Now, what is the lower endpoint for that area?
Starting
Negative
at
infinity.
Negative infinity, right? It started somewhere at negative infinity, all the way up to value of z, which in this case is -2. With me? So, in your calculator, press negative. Second, comma, negative, second comma, you will get that funky E.
Yes.
Right about 7. Press second followed by comma.
Yeah.
99. That would mean negative infinity. Okay? Where does it end? That area ends at 2. Right? So I'm going to put 2.
So shouldn't it be -2?
Oh, thank you, sorry. -2. That value.
Okay.
What is the mean of that curve? We're talking about z-scores, standard normal, 0. What is the standard deviation?
2, 1.
1. We divide by standard deviation, so 2 becomes 1. So for a standard normal distribution, the mean is always 0, the standard deviation is always 1. So I'm going to type in 0, comma, 1.
Wait, I did not understand why the standard deviation is 1.
You're dividing by
2
the
divided by
standard
2.
deviation. 2 over 2.
Oh, so we don't have to get like the amount of standard deviation from our point to the center.
From here to there. See, that is what that -2 is talking about. So starting at -infinity all the way up to -2. But what is the mean of the standard normal distribution? 0. What is its standard deviation in general? 1. Right? So negative in E99, which means -infinity up to -2, followed by 0. The standard deviation in that case is 1.
Does the zeros represent?
Um,
Does the zero represent?
the mean. Okay, so I get 2.275000062. Now that is accurate. Yet it's not close to 2.5%. Why?
Because we're not really doing it from infinity.
Even the calculator is doing an approximation, but that is not the reason. The reason is when we did the empirical rule, we just gave approximate values. These are approximate percentages, 68, 95, 99.7%. They are not accurate percentages. Does that make sense? Yeah. So the accurate value is 2.275, yes. Syntax error.
Are you putting in minus or are you putting in negative? That's
Press second answer to get a negative. Now, we already agreed earlier that what talks on it, sir?
Everyone's putting minus the minus sign instead of negative.
Pay attention, you know, stuff.
I'm trying.
So, what did you say? So, normal CDF,
Okay, so that's always.
negative E99 minus 2 gave us 2.27. Now, a z-score of -2 would correspond to which x value? 4. So if I use normal CDF for the original data, I will start at -E99, yes? Go all the way up to 4. But what should the next two values be?
8 and 2.
Very good, 8 and 2. So if I deal with the data, start at -E99, all the way up to 4, use the mean, use the standard deviation, I'll find the probability. But if I converted it to a z-score, that 4 over there would become -2. The mean would become 0, standard deviation would be 1. Yes,
So the last number, like for this example, we used 1 is always the standard deviation.
yes. So I'm going to show you that if I use the original data itself, second bars, number 2, negative, second comma, E99. I'm using the data, so a z-score of -2 would correspond to +4. 4, comma. What is the mean in this case? 8. What is the standard deviation in this case? 2. Should I get the same answer?
Yes.
Yes. Okay, let's see. Good. So even if MyLab Plus suggests convert it to a z-score, then find the probability done. So you can find it directly, unless the system wants you to find a z-score, you don't have to. You can find the probability directly. Good. Yes,
Did we learn to integrate in Calc 1?
come again?
Did we learn to integrate in Calc 1? Interesting.
Would we be expecting?
Oh.
So the next case, we want to find the area above 1. Of course, we can use the table, but here is 1 and 1.0.00 simply would mean the area below 1. Keep in mind, the calculator, the table is giving you the area below 1 or to the left of 1. What I asked of you was the area to the right of 1 or above 1. Well, if you just use the table and you got that number, how do you find the area above? 1 minus this value should give you the answer. But if you're using a calculator, which I highly recommend,
Are you gonna have that like table up for us on the test?
no,
You should.
Or you can print it and bring it on the cheat sheet.
no way.
Why not?
Why?
That's
What if we,
idea.
what if we write it all
What if we
out?
write it out?
I will handwrite all of that out for the cheat sheet. Is it legal? I'll do it. Okay, I'll do it.
I can put.
I will have.
That's kind of a waste of your space on the cheat sheet.
So
Depends how small you write.
where should we start? We should start at 1. And so the lower should be 1. The upper is E99. So 1, comma, E99, 0, and 1. We get 15.87% or 0.1587. Same process, but if you want to do it with the data, what would you do?
Oh, you just try to switch it to 0 and 1, so.
We will start at
10,
Oh, sorry.
10,
right?
end at
E99,
99, mean
8,
8, standard deviation
2.
2. The answer will be the same.
It's just easier to use the z-scores.
Good.
Is it, so is that over or under?
Under.
Under.